Solving non-right triangles, cosine law. The cosine law can be used to solve any type of triangle as long as you know all three sides or two sides and an angle opposite one of them. In triangle ABC, the cosine law states c squared is equal to a squared plus b squared minus 2ab cosine c. I want to point out here and even later that if you notice the side that's by itself on the left is the same as the angle in the cosine. That's very important. Example, in triangle below, find angle B. So we've given all three sides so the triangle is fixed, and we want to find out how large angle B is. So let's apply our formula. Note, in the cosine law formula, it is important that the side on the left in the formula is the same side that is opposite the angle in the triangle and the angle in the formula. So let's look at how we rewrote the formula. If you notice, I now have b squared because it goes along with angle b, and that's the angle we wanted. So we've got b squared equals ac squared plus c squared minus 2ac cosine b. We switched the formula around a little bit, but it's the same formula. Now we'll plug in our numbers. We have 32 squared equals 16 squared plus 22 squared minus 2 times 16 times 22 times the cosine of b. So there's only one unknown in that equation, so we're going to be able to evaluate it and find angle b. So first we'll square all of our terms that are squared, and we'll multiply that 2 times 16 times 22 out. And we get 1024 equals 256 plus 484 minus 704 cosine b. Now subtracting the 256 and the 484 from both sides, we get 284 equals a negative 704 cosine b. Then dividing both sides by the negative 704, we get that cosine b equals 284 divided by a negative 704. This gives us, in the decimal, that cosine b is equal to a negative 0.4034. But now we need to be able to get the b by itself. So we're going to take the inverse cosine of both sides. And the inverse cosine of a negative 0.4034 equals b. And then putting that into our calculator, where the inverse cosine key is, and we get that angle B equals 113.8 degrees. Now this is if you had your calculator set in degrees, and that's what mine was set for. If it was set in radians, then you'd have a radian answer here, and you might want to check to see if that's equivalent to the 113.8 degrees that I found.